Hey everyone, welcome to Cassandra Lunch number 109. We'll give everyone a couple more minutes to file in before we go ahead and get started. Hey everyone, welcome to Cassandra Lunch number 109. We'll give everyone a couple more minutes to file in and we'll get started soon shortly. And don't forget to get our 6th free Apache Cassandra runbook. The link is in the live chat. Just fill out the form and we'll send it over for free. Alrighty, let's go ahead and cut the music. Hello everyone, welcome to Cassandra Lunch number 109. Today's talk is going to be on DataStax's cql-proxy tool. The talk will be by me. I'm an engineer here at Anant. Co-organizers for this event are Rahul and myself. We are looking for guest speakers as well as sponsors. So if you're interested in giving a talk at Cassandra Lunch or our sister lunch, Data Engineers Lunch, feel free to reach out to me. My email is listed below. We are a part of Data Community DC. Data Community DC believes in building an inclusive environment, so no matter your race, gender, or sexual orientation, everyone is welcome, and we expect the respect to be given to all. Data Community DC is built of a bunch of different organizations. Our sister lunch, Data Engineers Lunch, falls under Data Wranglers DC. So if you're interested in all the various different organizations, feel free to check out datacommunitydc.org. So what do we cover here at Cassandra Lunch? We cover everything that is Cassandra, talks Cassandra, or plays well with Cassandra in the ecosystem, whether that be open source Cassandra, enterprise variants such as DataStax, Scylla, Yugabyte, Cosmos, Keyspaces, etc., as well as things in the ecosystem such as Spark, Kafka, Airflow, and the bunch. So if anyone's new here, say hi, hello in the YouTube chat. check if you're working with anything interesting in Cassandra and you want to give a talk about it here at Cassandra Lunch, feel free to reach out to us. Group roles, if you have a question, feel free to ask it. We're monitoring the YouTube chat, so we'll be able to see it right away. Be polite and courteous to others. Please respect each other, and please do share what you know with us. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is our bread and butter. DataStax is a partner and a sponsor. GW University helps provide venue space when we have in-person events. We have also have some organizational and institutional sponsors. If anyone has any jobs, meetup, hackathons, conferences, classes they would like to remote, feel free to drop links in the chat. Anant is hiring full-time or part-time positions, data platform operators, engineers, architects. You can find out more at careers.anant.us. So upcoming events, Data Engineers Lunch on Mondays at noon Eastern currently. And we also have Cassandra Lunch on Thursdays at noon Eastern currently. All these videos are available on our YouTube channel, youtube.com/AnantCorp. So if you're watching this on YouTube, don't forget to like, subscribe, and turn on the notification bell. But you're able to catch up all the way from Cassandra Lunch 10 till today's Cassandra Lunch on the Cassandra Lunch playlist. Cassandra.Link should be your #1 resource for all things Cassandra. This website is hand curated by the team here at Anant with all the resources that are in the context of Cassandra, as well as videos and news feeds as well. We've also released our 6th Apache Cassandra runbook for free. You guys can get it. I dropped the link in the YouTube chat, so you can click it, fill out the form, and we'll send it right over. And this one covers audit, trace, and load repair percentage. And with that, we'll go ahead and move on to today's talk. So before I begin, just because this takes a little bit time to spin up, I'm going to go ahead and open up this repo on Gitpod. So this entire presentation can be done on your browser. We're going to be using DataStax Astra as well as Gitpod. But with DataStax Astra, it's a free account, no credit card, etc. You can just fill it out quickly. So I'm going to drop this link in the chat so you can see my repo. So what we're going to do is go ahead and open this up in Gitpod. And while this is loading, what we're doing in the Gitpod YAML file is we're running a couple prerequisites, and we're going to install dependencies using pip install requirements. And then we're also going to start a Cassandra Docker container. And specifically, we're going to be using 3.11. We'll talk about that in a second. And then we're just going to start cql-sh and expose port 9042. So while this is spinning up in the background, the main thing is just the Cassandra driver. It takes a little bit of time to install. And so we're just going to let that happen in the background. But moving on to the slide deck. So again, today's talk is going to be on DataStax cql-proxy. And so what we're going to talk about is how can we use it from lifting and shifting it from a application or program that talks to open source Cassandra specifically today, but you could be using open source Cassandra, you could be using DataStax Enterprise, and then we're going to shift it to DataStax Astra using the cql-proxy. So if you're not familiar with the cql-proxy, it's an open source tool, so you can find it on GitHub. We'll drop the links. The links are also in the resources here. It's an open source tool designed to securely forward your application's CQL traffic to an appropriate database, in this case, DataStax Astra, while listening on a local address. And we'll talk about that once we get to the demo portion. But essentially, it helps enable unsupported CQL drivers to work with DataStax Astra, which includes legacy DataStax drivers or community maintained ones such as the Go or Rust drivers. And so you'll see in today's talk, we'll be using the Python driver. And we're purposefully going to be using an older version that does not have compatibility with a cloud offering like DataStax Astra. And so we'll talk about that once we get to the demo portion. But essentially, as mentioned before, you can also use applications that are talking to open source Cassandra or DataStax Enterprise, and then be able to essentially configure your code to then talk to Astra just by using the cql-proxy and then updating the configuration of where it is. And we'll show you how to do that in the demo portion. And then again, if you're building new applications with the new DataStax drivers, you don't need to use the cql-proxy because the new drivers obviously have the availabilities to use the secure connect bundles, et cetera, be able to talk directly with Astra. So some of the things to note are that you'll need to pass configuration into when you run cql-proxy. This can either be done by command line flags, env variables, or configuration files. Today, we'll be using the Docker commands we can see here. So there's a couple ways to do it. So here they have the flags here, the Astra token, and then Astra database ID. We don't need to use Astra database ID, and we'll take a look at that once we get to the demo portion. But if you wanted to do it with the flags, you can do it that way, or you can do it with the environment variables using flag E, or you could use it with a configuration file like here where they have their contact points. This is like the open source contact points, or if you're using Astra, they have some examples for that. You can find out more on their documentation. So there is a use case for using like a multi-proxy setup, and that's generally for like multi-region failover with DC aware load balancing policy. And then coming back to how you can run cql-proxy, right? There's three main ways you can do it. You can locally build it. Again, this is an open source tool, so you can get the source code, build it, right? And then you can run cql-proxy that way. I believe it's with Go. And then what we'll be doing today in today's demo is going to be using the Docker image, which we can run on Gitpod very easily. And the third option, which is using Kubernetes, which we won't be covering today. We're just going to cover a high-level overview of cql-proxy, some issues that I ran into while using cql-proxy, some things to maybe keep an eye out for. And they do note one known issue on their GitHub repo, and that's related to token-aware load balancing. And it mentions that drivers that use token-aware load balancing may print a warning or may not work with using cql-proxy. And if you want to find out more, you can read more on their GitHub repo. But yeah, that's just one thing to note with cql-proxy is that it may have some issues with token-aware load balancing. So resources here. Here is the main GitHub repo, the open source tool, obviously. We have a couple blogs from DataStax, the medium ones also from DataStax, talking about introducing cql-proxy, some use cases for it, like migrating your legacy applications to the cloud SaaS offerings like Astra, as well as the driver matrix which we're going to be talking about specifically and the reason why we chose the specific version that we're using for the Python driver and where this code is coming from. So in the demo portion, what we're going to do is what we've already done is spin it up on Gitpod. But again, we just did it a little bit early just because the Cassandra driver install takes a little bit of time. And then what we're going to do is we're going to run a Python program with the out-of-date Python driver, and we're going to make it talk to Dockerized Cassandra 3.11. And then after that, we're going to switch to using the cql-proxy to quote unquote lift and shift our Python application program from Dockerized Cassandra to have it talk to DataStax Astra without having to necessarily make significant code changes, right? And so that's the idea behind cql-proxy is, right, you don't have to make significant code changes to your already working applications in order for you to proxy to DataStax Astra. And then some potential issues that I ran into while running this demo, and some things to keep in mind when you're doing these, your lift and shift from your current applications to moving to Astra if you would like to do so. So now what we'll do is switch over to Gitpod. So we come here, we've seen that our Cassandra driver has now installed. So before we start, what we're going to do is take a look at our requirements txt file. We see that our Cassandra driver, we're specifically saying download 3.19, right? And so if we look at the Python drivers matrix here, we can see the driver version and we can see the compatibilities, right? So we're using 3.11. Our 3.19 version is technically, when you click on this link here, it'll take you to the 3.19. And we can see it's compatible with 3.0 plus Apache open source, which we're using today. But if we look further to the right, we see DataStax Astra, there's no compatibility here, right? So if we click on this 3.0 plus, we see Python driver 3.19, which is the one we specifically set in our requirements txt file, right? So what I do want to show you is if you go back to the matrix and we see that this 3.2, this is where it now enables cloud compatibility, right? So if we actually click on this 3.20, and if I search for cloud here, it actually shows you a guide to connecting to DataStax Apollo, which I believe is just what is now called Astra based on the instructions that they have here. It's essentially just saying, plain text auth provider, and then you have your secure connect bundle, etc. So this is mentioned on 3.20, right? But if we go back to 3.19, and if we search for cloud again, it doesn't come up. So we know that based on this matrix here, 3.0, quote unquote, 3.19, it does not have cloud capabilities, right? So what we've done is installed that specific version. So that way we can say, hey, we're talking to Cassandra 3.11, but if we wanted to talk to Astra, we technically can't, right? Because there's no supported functionality for it on that specific version of the driver. So what the proxy will allow us to do is, quote unquote, lift and shift our application, which is using the 3.19 driver, to then talk to Astra using the 3.19 driver, even though it's still not technically compatible, right, based on the matrix. So let's now go to the demo. So what I'm going to do here is move this README to my other screen. And so what's going to happen is I can just copy and paste going down the README. But actually, before I go there, feel free to drop questions or comments in the chat. If you guys have any, we can answer them at a good stopping point. But for the most part, feel free to drop them and we'll get to them. But let's go here. Oh yeah, so basic prereq, well, we already mentioned it, free DataStax Astra account, and you'll need to generate a token. And when you generate the token, we generated an admin token. But even though we generated an admin token, we do run into a small issue. But again, that's an Astra thing. We can't really do anything about it. But that's just something to keep in mind when you're working on it. But again, it's mentioned in the README, so you can follow along if you want, or you can do it on your own. Again, you just click that Gitpod button. It opens up for you. And so what we're going to do here is go into our cql-sh. So if we go to our Gitpod container, and then let's allow copy and pasting. All right, and then I'm just going to expand the view real quick. Let's command plus. Okay, so we're doing here is just we're going to say describe key spaces, right? So this is a clean Cassandra 3.11 installation, right? So what we're going to do first is run this Python file we have called data importer. So if you're familiar with this code, or if you're not familiar with this code, this was actually written with one of our workshop series that we did with DataStax related to Cassandra real-time. So if you're interested, you can find those videos on the DataStax channel, as well as the source code on our GitHub repo, or github.com/Anant. And you can find the Cassandra API or Cassandra real-time pinned on our pinned repositories. So you can check out this code here. We did make a little bit of modifications to it. So I did remove some of the stuff so this code originally, the original purpose for this was to import data directly to Astra. So what I did was I took out that functionality and I made it talk to Cassandra 3.11 in the vein of using the 3.19 Cassandra driver, right? So what we're going to do here is we're going to run this file. So what it's going to do is create a key space. It's going to create a table. It's going to take 10 rows of some of this Solar data that we have, and it's going to pump it into our Cassandra instance, right? And so we're going to do that using a insert query, and we're just going to insert it as JSON, right? So what we're going to do here is just re-expand this. Let's go to our other terminal, and coming back here. So what we're going to do here is just add a key space name and a table name. So I'm just going to say demo is going to be our key space, and our table is going to be called leaves, right? So what we're going to do here is it has some progression stuff that Obi, one of our team members who's on the live chat, I see you. Feel free to check out our Cassandra real-time repo again. But now that our importers run, if we go back to our cql-sh and we say select count from demo.leaves, we should get back 10, right? Because that's the number of preset rows we have, which is 10, right? So now moving down the README, if we kill our Cassandra container, because what we'll need to do is run our cql-proxy And because as mentioned before, it uses a local address to listen on, and we set it to say 9042, but we're technically done with Cassandra, so we don't need it anymore. But before we can reuse port 9042, we just need to kill our Cassandra instance, right? So what we're going to do here is run this command to start our cql-proxy Docker container. What we're doing is we're just going to use the Astra token. I already have this command copy and pasted, so I'm just going to copy and paste it using my token that I have for my Astra cluster. Let me grab it real quick. Let's go copy and let's go paste. Again, I'm going to destroy this token as soon as this demo is over, so this token won't be able to do anything for you. So let's go ahead and run this, and we'll see that it'll install the image. Takes a couple seconds. And it's now listening on 9042. And we see that, again, proxy is listening, address 9042. So, okay, we've now shifted our, well, let me explain how we're shifting it. So if we look at this cluster session here, we're saying sysargv1, which is essentially we're sending in our host name. So before we would say we would pass in our Cassandra cluster, but now we're going to pass in our host name. So if we actually just do host name flag I, we see two host names, right? This is the Docker host name. The cql-proxy is listening on this 10.5.2. And so what we're going to do here is take this IP address and pass that in as our host name. And so that's the change, right? So quote unquote, that's all the lifting and shifting we would need to do straight up to switch from our Cassandra container to our proxy to talk to Astra. However, when we run this, let me grab the command real quick. Let's paste it in. So again, as mentioned, we're going to run the data importer, and we're going to pass in the host name, first one, as arg1, right? And then for our key space name and demo name, we're going to say demo. And again, this is going to be talking to Astra, right? Because we're passing in arg1, which is our IP address for the proxy. But if we see here, we run into an error, right? Missing correct permission on demo. So what this has meant is with this proxy, or I think Astra in general, I think even with the Terraform, I forget, we talked about it. If you want to check that out, the DataStax Astra Terraform provider, it's on our YouTube channel. I think there were still some issues there with creating key spaces, but using even an admin token via CQL, it doesn't look like we can create Astra key spaces. So what we'll need to do, or if you have something you're just reusing, you can just reuse that one. So what I'm going to do here is just to show you, if you're not familiar with Astra, what you can do is just create a key space after clicking on your database. You just go to this section called add key space, and we just hit demo. And this should create our key space for us. And then if we go to our CQL console, just give this a quick refresh. Let's go to describe key spaces. And we see our demo key space, right? So then if we describe demo, we just see plain key space, no tables. So coming back to our Git pod repo, now if we try rerunning this command, it should work, right? We're saying, oh, sorry, I forgot. I need to go back to the README. We need to comment out some lines, apologies. So we need to comment out the lines that create the key space, right? So lines 20 or 19 to 23. So we have a sed command for you, so you can just run it and it'll automatically comment out those lines for you. So now if we come back and rerun this, it should still create the table for us, but it'll do it in the key space we provided. So in the demo key space that we created on Astra using the UI, create this table called leads. But wait, it still ran into an error. So One thing to note is pending the driver versions, they may have default consistency levels. And so specifically for this 3.19 Python Cassandra driver version, it defaults to local 1 as the default consistency level. So we can do some things to rectify that, right? So we can use execution profiles. That's one way to do it, right? Or we can just do it on the session level, set the default consistency level, which is what we'll be doing in this demo just for simplicity's sake, right? So if you see here on line 6, we import consistency level. And then if we scroll down here, it's currently commented out. So that way we can show you these errors and then fix them given said commands with you. But if we scroll a little bit further down, we can see here, we have this line session default consistency level. And then it's currently commented out, hence why it's defaulting to local 1, but we're going to change it to local quorum, right? So if we go back to the README and we copy in this new sed statement, it's going to then uncomment. Oh, sorry, that was the wrong sed statement. Let's go back here. It's this one. And so that's now uncommented line 144. And then because we've already created the table, because it made it that far down, right? It had an issue with actually writing the data in, but it still created our table. What we can do is just comment out the lines that create a new table. What if we just say describe demo? We should see our table leaves, right? Demo.leaves. So we come back here, data importer. We're going to run another sed command, which will comment out our lines that are for table creation. So if you scroll up to line 26, and we now have commented out our line creation. So now, hopefully, fingers crossed, when we rerun this, it should write 10 rows into our demo.leaves table, right? So if we do this, looks like it went through. Now, if we go into our Astra database and we do a select count from demo.leaves, we get back 10 rows. Looks like it worked. However, while going through this, again, as mentioned, if you have this just for like an API, maybe you might just need to change the session consistency level stuff. However, if you're creating key spaces, if you're creating tables via your programs that are using outdated drivers that can't talk to Astra, that's something you'll need to keep in mind when you're using a proxy, right? It can't do everything, but it can do most of the stuff and should be able to quote unquote lift and shift you relatively easy, right? Because all we really did was comment out some lines and then set the default consistency level for the session and just swapped the IP address, right? So instead of talking to a list of host names, we then just send our, we set our cluster connection to the proxy IP address, right? So now say if we want to add more rows, right? So if we come back into our repo, so right, our default value was just 10 rows, right? So if we go ahead and just swap from 10 rows to say 1,000 rows, and then if we rerun our code, it's going to take a little bit longer, but it'll work, right? So if we see it's running, so if we just do a select count, 66, 79. So while this is running in the background, what we're going to do is we're going to take a look at the questions and comments in the YouTube chat. So we see here, yeah, seems like a cool use case to be able to lift and shift your Cassandra application to other Cassandra instances, correct? Kind of like cql-proxy, which DataStax has, but it's not open source. So there is a question from OB. How does this interact with CQL's version changes? CQL has capabilities now like arithmetic operators that didn't exist in previous versions. Yeah, like Rahul mentions, I don't think it parses the CQL. I think it lets the destination deal with it. So based on DataStax Astra, which I think is running 4.0, if it supports arithmetic operations, I think it should be able to support it because, again, you're now sending your CQL to that destination, right? You're not sending it to your older Cassandra version, right? So as long as you're executing a specific CQL statement, whatever that CQL statement is in your session execute, I think whatever the destination is will interpret it. If it has arithmetic in it, and if you're using DataStax Astra, it should work fine. So OB has also mentioned in 3.4.4, alter type alter has been removed. A field type may not be changed after creation. So yeah, I think it's just in terms of whatever your CQL application is, or whatever your destination is. So if you want to add stuff to your current application and you need to make modifications. So again, as mentioned, if you have CQL statements that use alter, but it's been removed, then you may need to make adjustments for that because your destination is now something else on a higher version, which has now removed that alter functionality. All right, let's see. So let's see, however you can work around the issue. Yep. Cool. Yeah. Looks like that should answer your question, OB. Thanks, Eric. Thanks, Rahul, for answering as well. Feel free to drop more questions in the chat, but in terms of the demo, that's pretty much all I have. So let's just take a quick peek on this here. We see 1,000 rows now. And then if we go into our data importer, we can see 90% complete, it's completed. So if we just say a quick select ID from demo.leave. So let's just take one of these IDs. Let's say select tags from demo.leaves where ID equals this. So our data was imported. So, okay, looks like there's another question in the chat. Are the queries only getting sent to the proxy in Astra, or are they also getting sent to the old DB? No, we are only sending them to the Astra, the proxy, which then sends it to DataStax Astra. So if we look at the code here, so what I've done here is just made it so that I didn't have to have like a ton of code. I could just use system args, right? So in this specific line here, line 9, this is where we establish like our cluster connection, right? So typically the first parameter you give to the cluster connection is your host name, right? So in this list, we say sys argv1. So when we were talking to Apache Cassandra, we were just passing in, let's say host name I. So when we were using the Dockerized instance of Apache Cassandra, we were using this awk_print2, right, which is this 172 IP address. But once we started the cql-proxy container, we switched to using this one. So essentially, it's just you switch whatever your cluster is connected to. So that's the main configuration that they talk about in their README. But yeah, that's all about it for it to be able to switch from your specific application to be able to switch from whatever your database, your original source database is, to the proxy, which will then put you in the new destination. Okay. So Eric mentioned, I think you configure all queries to go through the proxy once it is configured, but yeah. So essentially you set the proxy as the cluster connection string, essentially your host names. So your proxy, whatever IP your proxy is running on, that becomes your new host name to put in. So you switch out your old host names for your new host name, which is the CQL proxy, which then securely handles talking to Astra or whatever destination you want to put it at. Because again, you can use the proxy to send it to Cassandra, DataStax Enterprise, or DataStax Astra. But I think they want to push you to do it to Astra. Okay. I don't think there's any more questions. So let's see. That should wrap up all I have for today. So let me go ahead and stop sharing. Thank you everyone for joining us here for Cassandra Lunch. Don't forget to check out next week's Data Engineers Lunch as well as Cassandra Lunch. And with that, we'll go ahead and wrap up. See everyone next week. Take care.